Welcome back to the classroom. My name is Mr. Wong. We're going to be going through some past paper questions on the kinematics, module 1 of Year 11 Physics. So we are going to go through the 24/7 community service questions. So we have a velocity time graph, as you can see here. Just a quick revision for those who have forgotten what kind of information we can get from a velocity time graph. Just remember the gradient, so this line here, the gradient actually tells us the acceleration of the object. How do I know it's the acceleration? Well, if I have a look at this here, if I look at the rise, so the y-axis, you can see how velocity is changing as we go up, right? So we have the change in velocity over, so divided by, you can see time here, the change in time. So the change in velocity over the change in time is obviously acceleration. So that's what we have there. Another piece of information we can gather is what's underneath this line. So what is the meaning of the area underneath this line here and our zero axis here and also this part here? What type of information does that tell us? Well, according to the area formula, it's the height times the length, right? So it's or height times length or width times height, whichever one you want. So the height we have, the rise that we have, is velocity, or the change in velocity, times this one, the change in time, and that gives us displacement. So the area of a velocity time graph can tell us the displacement an object's traveled, and the gradient will tell us the acceleration of that object. So hopefully that makes sense. Okay. So let's go to our questions. So question A, it says using point P as the starting point, draw a labeled vector diagram, essentially using arrows, to show the path taken by the object during the 30 seconds it traveled. Include the displacement of the object. Okay, so let's get back up to our graph here. Okay, so we want to know the displacement from 0 to about 18 seconds. And then from 18 seconds to about 13 seconds, what's the displacement there? So if we actually just zoom out a little bit, give myself a bit more space, and then you can see my working out. So from the time of 0 to 18 seconds, we need to split this table up into its area components. So I'll just get rid of some of these lines. So we have one triangle here, this length here. So that's area 1. We have area 2, which is this rectangle around here. And then we have area 3. What we notice is now the velocity line has gone below 0, and that means the object is going backwards. So in this spot here, it's going north, or this area here, it's going north, and then from this area onwards, it's going south. Okay? So again, we can split into area 4 and then area 5. Okay? So we want area 1 plus area 2 plus area 3. Area 1 is a triangle, so it's half times the height, which goes up to 4, times the width, which is 5, plus area 2, which is a width of 10, a height of 4, plus the triangle that we have here, area 3, half. We have a timing of about 3 seconds past, and we have a height of 4. Okay, so the overall displacement is 56 meters north. Okay. And what we have at the 18-second mark, from 18 seconds to 30 seconds, we have area 4 plus area 5. So that means it's half 2 for the time passed times 2 plus 2, the height, times the time passed of 10 seconds. So let's see how long that is. And that's 22 meters south, which actually tells us, if we're looking at the net displacement, so S net should be lowercase s, S net is equal to 56. Let's assume going north is positive 56, subtracted by 22. And that gives us a overall displacement of 34 meters north. Okay, and that's what we're dealing with here. So we need to try and draw that in our vector arrow diagrams. Okay, let's go to it now. Zoom back in. Okay, so we firstly go 56, I think it was meters we used. Meters, yep. So we go 56 meters north. So 56 meters north, 56 meters north. And then from there we go 22 meters south. So I'll do that in a different color. 22 is about this section here. So 22 meters south. Okay, and then we can draw the net displacement. So therefore the net displacement is is 34 meters north. And that's how you do that part of the question. This took an interval of 0 to 18 seconds. This one was the interval of 18 to 30 seconds. Okay, so there you go. All right, next question. It says, using the information provided from the velocity time graph, describe how the acceleration of the object changed at each time interval. Okay, so let's have a look. If we're talking about acceleration, remember we're talking about the gradient. So this gradient here, this gradient here, this gradient here, and this gradient here. What information does that tell us? Whoops. What information does that tell us about the object's acceleration? So here we can see in the first bit we have a positive acceleration, so it's increasing in speed. Here it's a flat line for velocity time graph. That means there's 0 acceleration. And then down here we get a negative acceleration, which implies that the object is now slowing down and then accelerating in the opposite direction once we get from this point onwards. But we'll say it as in one acceleration motion. And then you can see here it's also constant again, so there's no acceleration. So we're going to split it into a couple of time interval categories, from 0 to 5, from 5 to 15, 15 to 20, and then 20 to 30. So let's write that down. So let's just do that. So at time interval 0 to 5 seconds. Object accelerates at, and then this is where you can sort of show the calculation. So acceleration is equal to the rise over run. So I think the rise was 4, the run was 5. So 4 over 5. 4 over 5, or what we can say is 0.8 meters per second squared north. And then from 5 to 15 seconds, the object travels, whoops, mistake there, at a constant velocity. You can say there's A is equal to 0 meters per second squared. Then accelerates south at a rate of, let's see what the rise is for that case. So it goes from 4 to 2, so a rise of 6, and it has a run of 5 seconds. So 6 over 5, so 1 over, or 1.2 meters per second squared. I don't need to write the direction here because I already said it's accelerating south. So then accelerate south at that from 15 to 20 seconds. Okay. And then it remains at a constant velocity of 2 meters per second south. I guess the other thing I didn't mention early on, so you could talk about the accelerations here, or it is asking for the acceleration. So acceleration is 0, constant velocity. We could also mention that acceleration is 0 meters per second squared. If the question was just asking about what is the motion, then I could just say constant velocity at whatever value. I didn't have to write that acceleration was 0 there. But this is how you would approach the question. See how we broke down each time interval, sort of little subheadings here and there just for our marker to see. So that's how you would go about describing a motion time graph. You try and give the numbers where possible, particularly when you're given a graph. If they give you a graph, then most likely they want you to use the data from the graph in response to your question. Okay. So that concludes this response, or the explanation of this response. If you found it useful, like and subscribe, and I'll see you next time.